Welcome to clickmyproject.com. This video will lead us to the complete demo of seeking quality of web service composition in a semantic dimension. Let us see the abstract of our process. QoS-aware dynamic binding of composite services provides the capability of binding each service invocation in a composition to a service chosen among a set of functionally equivalent ones to achieve a QoS goal. For example, minimizing the response time while limiting the price under a maximum value. We propose a solution for achieving functional level service categorization based on an ontology framework. Additionally, we utilize clustering for accurately classifying the web service based on service functionality. The semantic-based categorization is performed offline at the Universal Description Discovery and Integration (UDDI). The semantic enhancement of the service request achieves a better matching with relevant services. Our quality measurement is classified into two as functional and non-functional quality metrics. The service request enhancement involves expansion of additional terms derived from ontology that are deemed relevant for the requested functionality. This paper takes a specific interest in combining semantic and non-functional criteria such as quality of service to evaluate quality in web service composition. Let us see the flow of our process. We take WSDL dataset as input. Then, for each of the WSDL files in this dataset, we follow the same procedures. We apply these procedures. Data pre-processing. In data pre-processing, we are removing the repeated words and POS, parts of speech. After removing these in WSDL files, we are identifying the service description. And then data clustering. Data is clustered based on the relevant area, the relevant domain. The data, that is the WSDL files, will be clustered. After data clustering, service categorization is applied. In service categorization, we are labeling the services, we are labeling the WSDL files as what is the original category of the WSDL file and what is the clustering category of the WSDL file. This labeling is occurred in service categorization. After service categorization, we are computing the quality. The quality is classified into two here. One is functional quality metrics and another one is non-functional quality metrics. So we are calculating both functional and non-functional quality metrics for each of the WSDL files in the data set. So after applying these techniques, we are storing all these details in the database, and these things are happening in the offline, which means these processes are occurred not while the user requesting any services. So we are saving all these things in database. Then while the service requests are requesting any type of services, first request is enhanced by applying data pre-processing for the request given by the service requester. After service request enhancement, we are applying semantic matching. So after request enhancement, we will get only the important terms, only the semantic terms from the user request. So by comparing these semantic words from the request enhancement, we are comparing it to the database from where we stored all these data categorization, pre-processing the semantic words. We are comparing these two things, and after comparison, we are getting the related services from the database, and we are ranking those services. This ranking is performed based on the service categorization. The request belongs to a category which is listed first, and the relevant categories are listed after that. So the services are providing to the service requester. Let us see the execution of our process. we are going to pre-process the WSGL files. Click on service description. So here we are having 6 types of WSGL files: communication, logistics, marketing, travel, utilities, and weather. For each of the services, we are having service description. We are going to remove stop words from these descriptions. Click on remove stop words. Here the special characters and the repeated words are removed. Click proceed. Click on service discovery. So here we are having a list of services in each of the WSGL files for all for all 6 categories. Click proceed. Click service vector. So here we are having the output of each of the WSGL files in each category. So in this file, this returns the weather for a given US postal code. Likewise, for all of the WSGL files, it will return the output. The output is showed here. And here, the repeated words, that is data pre-processing, is applied here for the output of each of the WSGL files. Click proceed. Click cluster. Now we are going to form cluster. Click OK. So here we are having 6 types of WSGL services. So we are clustering all 6 services. So it will be displayed for 6 times. Click OK. Once the cluster is formed, it shows us cluster formed. Click OK. Click show. Here we clustered services. After clustering, it will contain, for example, in communication domain, we'll have now we are having 18 files, 18 WSGL files, but previously we are having previously we are having only 13 in communication file, but after clustering we are having 18 files. That is, we are adding the related files too. So likewise, for each of the category, we will have the related files too. So this is called service clustering. Click proceed. Click on service category. Now we are going to labeling the services. Service categorization completed. Click OK. It shows the service type, the file name, and the category. So we added the marketing service type, this file, into the category communication, and we added travel service type file into the marketing category and other types into this category as it is related to these categories. Click proceed. Click on F and NF quality, that is functional and non-functional quality. Quality computation completed for service type communication. Likewise, for each of the service type, the quality computation is processing. Click OK. It is for logistics. It is for marketing. It is for travel. It is for utilities. It is for weather. And now the service quality computation has completed. This is the service type, the file name. This is called common description rate, and this is the execution time for each of the files in each of the service type. And these are the processing memory for each of the files in each of the category. These are the common description rate. Click proceed. Now we are going to search WSGL files. Click search. Click pre-processing. This is called request enhancement. So here the parts of speech words are removed. Only we are having the semantic words. Click similarity matching. So click on similarity matching button. Here the similarity matching files are these things. click service refinement. We are going to refine these services. So click service refinement. So here we are having, now you can see the difference. So the first file is US weather, but in previous window it is air temperature. So we define the services, click proceed. So these are the types of files we are having. Click on each of the service, you can view the particular file. So click here, and hence we achieve the efficient service refinement, and we achieve the quality service, and we measured each of the services using few quality metrics. Number one is functional and number two is non-functional quality metrics. As we combining two quality metrics, it will be more efficient and it will give the service requester an efficient service. Thanks for watching.